Alright, so here in this lesson we will discuss different embedding types. We will briefly talk about the shortcomings of pre-trained word embeddings and how we can make them a bit better. So what we did in our previous session was that we used individual word embeddings where each word is mapped to a unique identifier, which is then mapped to a specific vector. One disadvantage is that you need to learn a specific representation for each word and also often each variation of the word. So if you, for instance, have the word to go and want to use a representation for its past form, basically like went, then you would need to have a different embedding for it. And this substantially limits the amount of words overall, which is called the vocabulary, that can be represented by word embeddings. So what some people proposed was to use character embeddings, where basically each character is mapped into a single representation, and you then aggregate those by, for instance, averaging them or concatenating them. The second issue of word embeddings is that they are basically not contextualized, so they are learned once. And while there have been some works that try to look into learning different senses of a single word, they usually struggle to identify the correct context where the word actually appears. So a new idea what has been proposed, where instead of using a single word or individual characters, which is also problematic since there are a limited amount of them and each of them gets assigned a fixed representation, was to use something like subword units. So basically tokens or words are basically split into subword units that are learned on large amounts of data, which are then mapped to an individual representation. So the cool thing is it's something like in between both. So this gives you like a mix of more sophisticated representations that you would usually have in word embeddings and the granularity that you often have with character level embeddings. So now what Devlin and I proposed were to, instead of fixed representations, to use contextualized word embeddings. So basically generate embeddings based on the whole context of a word, or in the case of transformers, a fixed window which they use, which generates basically embeddings, for instance, for the word dog that is really influenced by the words my, is, and cute, and they further introduce additional tokens. So the CLS token, it's basically the classification token, which can be used for classifying the whole sentence. And the separating token marks basically separating sentence. So when using Hugging Face, it's important to keep in mind that the tokenization of words into individual subwords, you need to mark them in a way that you can recreate the original word. So how it is done here, it's that you add two of these hashes if the word is basically a part of the previous word.